Okay, we're going to now look at another point on this structure. Instead of 1 foot in front of the, to the left of the joint, I'm going to go 1 foot to the right. And I could go 1/100th of a foot to the right, and it would still not change the basic mathematics of this. But we're first going to do that and point out you can do this once you have your vectors, your determinants of all the forces about some logical 0, 0 point. You can do it mathematically without having to do this CAD shifting. I'm just going to do the CAD shifting because I can. Again, we're going to do and because I don't have a calculator in front of me, which is not a good thing. The intersection of there, I want to move this all I want to move it 9, 0. Did that wrong. Move cross from here at 9, 0. So I'm putting everything back where it started. This, of course, you're going to see is so you can do a data extraction. I will point you out to that one, and you can use these two things together. Now I'm 10.1 to the right, so I'm going to move this thing, now move it again back, cross, from any old point, at minus 10.1, 0. Now if you notice, what's behind me is not important, but it has to do with load path. So the only thing that falls out of this equation now is that support behind me. Now I can do it the other way, and I'll do that in a second. So that means in this case I can just turn around. I can turn around, but then my moment and my shear definitions are completely reversed. It's Newton's equal and opposite law. And so because of that, I'm just going to do the more extensive math, which is to do all of what's in front of me is important. Now what I have to do is now I realize what's behind me is not important, so I can't erase, but I can use a pen here, and this is not important. However, I need to shift my coordinates now, and you don't have to, it just makes it easier. And so this one here, instead of being at 0, 0, we know that one, these are at minus 10.1. This is also at minus 10.1. This one, of course, if we go ahead and do the math of 4.62 minus 10.1, we get minus 5.48. All right, this one here, wow, that would be up. It's 0, isn't it? I'm sorry, it's minus 0.1 because you're subtracting out 10.1 from 10, and that kind of makes sense. This next one up, it would be what? If you're looking back, your coordinate system is this, it's going to be 2.4. And this one is going to be 4.9. What's behind this is not important. You add up all the forces here, minus 3.30, 3.54, minus 2.83, and 0. And your internal reaction is the opposite of that in the x. You add up all your forces. In the y, your internal is the opposite of that. And I'll leave that to some kind of basic editing on YouTube, and hopefully a few of you will start to do a couple of these as I leave just that basic mathematics out of it. And then the determinant here, again, if we're going to the determinant here, well, this one is going to be, well, that force there, if you think about it, that reaction force in the x, so I'm going to put them what they are right now. This is the RF in the x. This is the RF in the y. This is actually 10 force. This is 11 force. This is 12 force. This is 13 force. And this is the reaction at B in the y. And now if you add up all of these and take the opposite, you get the interior moment. We'll go ahead and show you what that up. See if I can do an erase here. Again, working from the left side, your free body diagram looks like this. You replace that with a force P. It's going to be positive, or T. It's going to be positive in tension. A shear force that's positive down. That's how you do the mathematics. and a moment force. Remember, a moment, by pure definition, is something that causes a positive turn in the internal compression in the top fibers, tension in the bottom. Now, if you're going to draw, and if you do those sums on this, you get the mathematics and you figure out what is the reaction there. However, let me go ahead and show you what the free body diagram looks like. In this case, this is positive, opposite direction, same sense of tension. Shear is positive that way, and moment is positive that way. So if you do it that way and you use the same mathematics of what's behind us is not important, you go tick, 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 you go with your back to there. Now you have basically only one force, and that force here is going to have a determinant. All right, that is now a positive 9.9, 0 in the y. It is still this 0 and 5.17. If you look at those calculations, this is the external moment is going to be spinning positively, and so this has to, in other words, this here, if you look at this like this, it's spinning back this way, and so you need to spin back the other way. And so your moment is going to be equal and opposite to that. So, in other words, this is pushing up this way if you're looking back, and so this has to push back. So I'm going to tell you my general sense, no matter when I do that, is it's easier sometimes just to always work left to right, and I'll actually make the problems that way. Now, where it gets a little bit more difficult and where you just have to use this logic here is when you go right to left because the cantilever is coming from the right side. All right, so let me go ahead and review here, do all this erasing here, how we went about doing this problem, and I will point you out to, this is the second video. You can do anything on this structure. You can go anywhere on this structure and solve for the internal moments. And I'll talk you through a couple of ones. If you want to know just to the right of this, obviously you could write to the right side and do those, but you could just say, oh, well, now my 0, 0 point is here, and effectively I would not only be subtracting 10.1, I'd also be subtracting this 5. And so your radial vector, for instance, to here would be something like minus 10.1 and then minus 5. That would be this force here. Now you notice that force would then have a moment. And your radial vector here would be the same. And the mathematics is exactly the same. So if you look at this here, 4.62 is going to be a negative something and then a negative 5. So that's how you go about deciding that what's behind us is not important. And that is the same, believe it or not. It is the same basically of what we did in class, which is we could add up all the vectors to the right by sliding. Remember, we had this one this way, and we had this one this way, and we had to add them together, and then we take that vector and add them together. It's exactly the same, and yes, in fact, it is easier. That's in fact why we've done so much in terms of using determinants and matrices, and I presume all your classes, but at least in mine. All right, so that's this process that you go through. What's behind you is not important. You stack up all your reactions, and I will point you to an additional video, which I'll put out. This will be a series of 3, while I have solved for the reactions. But essentially what you had, you didn't have this to start. You didn't have this to start. You had this, 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 and this, and then you set this equal the opposite of those. So more or less you had a force here, a force there, 1, 2, 3, 4. You had 4 moments about the 0, 0 point, and you had to solve for the reactions. And then, once you did that, right, now you solve for going backwards, this, 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 and you got the reaction in the y, and then you had to write it about some other point. So I will go through that a couple different ways in solving for reactions. But what are the steps? The steps are basically you write up from the 0, 0 point all of your radial force pairs, including all of your reactions. And then you walk backwards along the structure, and wherever you get to, you subtract that radial vector from all of your force radial pairs. You erase out in your head what's behind you. So in this case, we started by erasing out everything behind us, right? So we were looking at the original point, which is 9.1, so everything behind us. And then all of a sudden, when we stepped 1 foot back, we had to then include everything but the reaction. So that's how you go about doing these. I would give them a try. I will do these for trusses and for fixed frames as well. The process is the same once you've actually figured out the reactions. Thanks for listening.